Okay, now let's think about sorting a little bit more complicated numbers. So here, it's not a complicated case. The idea is this. You're gonna sort the array numbers based on the absolute value. Okay, and then if the absolute value is the same, negative numbers first. So if you see this, 7 numbers, and then you see these are sorted based on the absolute values, and for 32, minus 32 and 32 who have the same absolute values, minus 32 goes first. Okay. Interestingly, our sorting algorithm, selection sort, is kind of robust. So there's only some portion of code that needs to be changed. So let's go back to source C. And what do I mean by that? So in a sense, like having this sorted area, unsorted area, expanding the sorted area a bit by bit, and finding the first index to be put is basically holes for whatever like the sorting elements, whatever way you sort the elements. The only thing that is a little bit problem is how do you change, how do you find the first element here? Okay, and that's the problem. And here we actually use, in before we used ascending order. That's why, we have that. Okay, so to generalize a little bit, okay, we're going to introduce before function. What I'm saying is this: if I should be, a sub I should be before a sub k. So before function means what? So here before function is outputting Boolean, and it's the double. You compare two numbers, okay? And before function is returning true if I should be before V in the sorted array. Okay, so in the normal sense, okay, if what A is B less than B, right? If it's in ascending order, if A is less than B, then A should be before B. And then otherwise, meaning B, if B should be before A, then it should return for false. Okay, so this is the right way. More sophisticated way, this is the same as this, but more sophisticated way to say this is this. See, if A is less than B, this will be true. So it's going to return true. If B is less than A, right, then this will be false. And this is returning false. So in a sense, 4 lines will be compacted into 1 line. Okay. Okay. So now let's look at it. So how do you find the first index? If A sub I should be before A sub K, well, K should be the first index. Make sense? So let's just compile that again, see if it works fine. Oh, yeah, I have to include bool. Okay. So now enter, let's say 4 and then 7413. Sorry, 7314. Okay, so it's sorted well. Now let's move on to our goal. The goal was what? Change the before function so that it's sorting according to the absolute value. So that means what? A should be before B, if absolute value A is less than absolute value of B, right? It will return false if absolute value A is greater than absolute value of B. The remaining, a little bit more complicated case is what if uh, they're the same. Well, then what? Negative first. So if A is negative, return true, right? Otherwise, return false. Okay, so that's basically the idea. Okay, so if this is the case, return false. Oh, there's, if you want to use abs function, absolute function, you have to include math. Math.h. Okay, so absolute base basically returns of absolute value. Else if and this is, oh, this is true, and this is false, and then else, what if this is things, A is negative, you gotta return true, else return false. Okay, make sense? So A should be before B if absolute value is less than that. Okay, let's try that. Okay, this is sort of C, and then lay that out. 7, and let's copy and paste these numbers. Okay, it's sorting well. Okay, a little bit more sophisticated way to write before is this. So if you really think about it, this can be compacted like this. If they're different, return this. So this is basically returning true or false based on the absolute value comparison, right? Because this is Boolean type. Otherwise, okay, again, this is compacted what? Return this. Then if it is true, true, otherwise it's false. So this is a simpler way. Okay, let's try that. 7, and then paste. Still is sorting good.